All right, so I want to just carry on talking a little bit more about the 6 trig functions on the xy coordinate plane. We talked about what they are and how to calculate them. And I gave you a try one. So I'm going to draw the one that I had on here. And I said that this coordinate here is -3, -4, which means it has an x and a y. The x is -3, which means I'm going back, technically, if I were to really label this, I'm going back to -3, and I'm going down 1, 2, to, whoops, that's not very good, but to -4. So I go over -3 units, and I go down -4 units, and that's how that coordinate was developed. And if this is my theta. The sine is always, the sine of an angle is always the ratio of the opposite side over the hypotenuse. The cosine of an angle is always the adjacent over the hypotenuse. The tangent is always the opposite over the adjacent. Then we have the cosecant, which is the reciprocal of sine. We have the secant, which is the reciprocal of cosine, and we have the cotangent, which is the reciprocal, oops, I forgot my theta. So hopefully you noticed that this was a 3, 4, 5 common right triangle. Okay, again, if you weren't able to figure that out, you can use a squared plus b squared equals c squared. You get -3 squared plus -4 squared equals c squared. This is 9, 16. So this is 25 equals c squared. You take the square root of both sides and you get c equals 5. So there's my 5 for the hypotenuse, and again, the hypotenuse is always positive. So the opposite side to the hypotenuse, let me pick a different color here. The opposite side of my triangle, this is the opposite over here. This is the adjacent, and this is the hypotenuse. The opposite to the adjacent is -4 over -3, or excuse me, -4 over -5. Ugh, I just said -5. -4 over +5. The cosine, again, is the adjacent over the hypotenuse, so it's -3 over +5. And the tangent is -4 over -3, which makes it +4/3. And these are really easy to do once you get your 3 sine, cosine, tangent. It's very easy to find the cosecant, secant, and cotangent because we just flip those numbers. Now, what you might notice is that the tangent was 2 negative numbers, so the tangent was positive. So here's a coordinate plane. It also looks like a plus sign. The tangent was positive. All right, and in the previous video, when we had our 8, 15, 17, it was -8, this was +15, and this was 17. The sign was positive. In quadrant 1, all of the trig functions are going to be positive. And if I were to do another triangle, which I'm not going to do it because it's getting crowded around here, the x value would be positive. This value would be a positive value, and this value would be negative. This is being the y value. The cosine would be positive. So let me come down here and I'm going to describe that a little bit better. We said that the sine function is opposite over hypotenuse. I'm going to draw a couple of triangles on here, just so that we can get a better visual on this. And I'll do them in different colors, so give me 1 second here. Oops. Okay, because all of these have coordinates, right? Here's a coordinate, here's a coordinate, here's a coordinate, here's a coordinate. And so in order to find the coordinate, right, we always have to look at the x, y. So this side right here, if I'm looking at the green triangle and this is my theta, this is the opposite side, this is the hypotenuse, and this is the adjacent side. All right? Now the adjacent side, notice, is the x value. The adjacent is always the x, and the opposite is always the y. It's always the height. So when I'm talking about the sine being the opposite over the hypotenuse, another way to say that is, and the hypotenuse is always going to be 1 because, again, if we're talking about the unit circle at least, the sine will always be the y value. And in quadrant 1, both x and y are positive. The cosine, which is the adjacent over the hypotenuse, sorry, I keep forgetting my little thetas in here. It's the adjacent over the hypotenuse, and so that's always the x value. And the tangent is the opposite over the adjacent, which is y over x. Now in quadrant 1, all of these are positive because x and y are positive. So if I go back to the little mini plus sign that I had drawn before, every one of those 6 trig functions is positive. So I'm going to write all. Oops. All. They're all positive. If I go into quadrant 2, my x is negative, as it always is. It's negative x and positive y. Any coordinate in quadrant 2 has a negative x value and a positive y. Well, if the y is positive, then the sine function of this angle will always be opposite over hypotenuse. And the hypotenuse is, again, always going to be a positive value. The opposite in quadrant 2 will always be positive. So the sine function is going to be positive in quadrant 2. However, the x value, this y is positive, this x value is always going to be negative. So because cosine relates to the x value, cosine will be negative because the x will be negative in quadrant 2, and the tangent will have a positive y but a negative x. So at the end of the day, the tangent is negative. So sine is the only one of the trig functions that should be positive in quadrant 2, and its reciprocal cosecant. Okay, its reciprocal always follows the same sign as the basic 3. Now if I go into quadrant 3, notice our x value is negative and our y value is negative, always. It's not just special for this situation. It's always a negative x, negative y to make this coordinate. So that means that the sine value of this theta right here will be negative because sine is opposite over adjacent, or it's the y value. Sine is always the y value, and this is a negative y, and this is a negative x. So sine is going to be negative. Cosine is also going to be negative because cosine pertains to the x value. So cosine will be negative. Tangent is y over x, and since both of them are negative, tangent ends up being positive. And I hope you guessed, therefore, that the cotangent will also be positive. Lastly, in quadrant 4, we have a positive x and a negative y because we're going down. So in quadrant 4, x's are positive and y's are negative. Any coordinate, not just with trig, but in quadrant 4, x is always positive, y is negative. So if y is negative, then the sine function will be negative. The cosine function, however, because the x is positive and the hypotenuse is always positive, is going to be positive. And therefore, so is the secant. And then the tangent will have a positive x, but a negative y, making tangent negative. So if you notice in this little plus sign here, in quadrant 1, all of the trig functions, all 6 of them are going to be positive. In quadrant 2, only the sine is positive and its reciprocal cosecant. In quadrant 3, only the tangent is positive and its reciprocal cotangent. And in quadrant 4, the cosine is positive and its reciprocal secant. So we have a little acronym for this. We call this acronym All Students Take Calculus. All students take calculus. And that means that all trig functions are positive in quadrant 1, only the sine is positive in quadrant 2, only the tangent is positive in quadrant 3, and only the cosine is positive in quadrant 4, and then they're reciprocals, okay? So that's a quick and easy way to check your work to make sure that if you're doing one of the triangles like we did up here, that you have the correct sign on your function. So let's double check my work up here. Get some of this out of the way. So my original triangle, I was talking about this 3, 4, 5 triangle that I had laid out in quadrant 3. So I just said that in quadrant 3, only the tangent should be positive. And if we look at my work, we can see that I'm verifying that because the tangent is positive. In the previous video, if you look at the second quadrant, you'll notice that the sine of that 8, 15, 17 triangle is positive, and the rest are negative. So my little trick of all students take calculus works, and it's a good way for me to check my work to make sure that I got the right function. It's also helpful when we start talking a little bit more about the unit circle, which I'll do in my next video, and reference angles. And it's going to help you to not have to do so much work. All right, good luck.